Hi guys, welcome back to my YouTube channel. In our last video, we solved about 4 questions on arithmetic progression. In this video, we'll solve extra 4 questions on arithmetic progression. And in our subsequent video, we'll solve some questions. We'll talk about geometric progression, solve some questions, and do a miscellaneous all-round arithmetic and geometric. So before I continue, please do not forget to like, share, and subscribe to my YouTube channel. So the first question says, how many terms does the sequence have? So we have -1, 4, 9, to 54. So before we know if it's arithmetic or not, we have to check. So 4 minus this guy, 4 minus 1. This guy is -1. So we have 4 minus times minus gives you plus. This gave me 5. 9 minus 4, that will give me 5. So we got 5, 5. So that tells us that the common difference is 5. So, and we also know that the first term, this is the first term, it is -1. So we know the first and second term. Now, remember that there was a formula I gave you that last term is A plus n minus 1 D. Now, we can see that the last term here is 54. And the first term is -1. So this n is not just any n. It is the number of terms that makes this guy to be last term. So this guy n cannot be any other value other than the number of terms that make this guy to be last term. So this is -1 plus n minus 1. Then D, our common difference is 5. We are actually looking for n, which is the number of terms. How many terms the sequence have? So we have 54 equals to -1. If I use this guy to open this bracket, I will have 5n minus 5. Then if I take this guy and this guy to the other side of the equation, I will have +1 plus 5. The negative becomes positive. So 5n is equals to 6 plus 54. That will give us 60. So if I divide both sides by 5, our n will be 12. So it means that there are 12 terms in this sequence. So let's check if we are correct. First term is -1. Add 1 to it, we have 4. Add 1 to it again, we have 9. Add 5 rather. Add 5 again, we'll have 14. Add 5, we'll have 19, right? 19. Add 5, we'll have 24. Add 5, we'll have 29. Add 5, we'll have 34. Add 5, we'll have 39. Add 5 again, we'll have 44. Add 5, we'll have. So if I add 5, I'm getting this. Add 5, 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 add 5. Then add 5 again. That will give me 49. If I add 5 again, that will give me 54. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can see that our 12th term was 54, which is the last term. So that's for the first question. Let's solve the second question. So suppose 2x, y, and z, 22 is an arithmetic progression. So we know that a is 2. Our last term is 22. How many terms are in this sequence? We have 1, 2, 3, 4, 5. We have 5 terms in the sequence. So we'll still use that same formula. Why? Because we have a last term and we also want to use to find the common difference because we don't know the common difference. So last term is 22, first term is 2, plus there's no way we can know the common difference because this guy is unknown for us to subtract here. So we have n minus 1. We'll be using n as 5 because it has 5 terms. Then our common difference is what we are looking for. So 22 is equals to 2 plus 4d. If I take this guy to this other side, I will have 22 minus 2. That gives us 20 over 4d. So if I divide both sides by 4, our d becomes 5. So it means that our common difference is 5. So common difference is that number will keep adding. So it means x will be 2 plus 5. Because to get this next number, I have to add 5 here, which is x. So that's 7. Y will be the next number, which is 7 plus 5. That will be 12. Z will be the next number, which is 12 plus 5. That's 17. If I add 5 to this again, I will get 22. There are other ways you can solve this. We know that the common difference is this minus this. So we x minus 2, or it is this minus this, y minus 2, or it is this minus this, z minus 2, or it is this minus this, which is 22 minus z. So we can pick any two of these equations to form. I can pick this one as equation 1, pick this and this as equation 2, pick this and this as equation 3. I'm okay with only 3 equations because I'm looking for 3 things to get my x, y, and z. You can try that out and show your work in the comment section. The seventh term, the 7th and 11th terms of an arithmetic sequence, they said the 7th term is 7b plus 5c. We don't know. But we also know that 7th term is a plus 6d. How did I get 6? 7 minus 1. So let's keep that information. Then they also said the 11th term is 11b plus 9c. We don't know what b and c is, but we know that the 11th term is also a plus 10d. How did I get 10? 11 minus 1. So I'll be working with these two guys. So we have a plus 6d equals 7b plus 5c. Then we have 11b plus 9c equals to a plus 10d. So if I subtract, sorry about that. Our second equation is a plus 10d equals to 11b plus 9c. So if I subtract this equation so that I can eliminate this guy. So if I'm doing this guy minus this guy, that will give me 4d. This guy minus this guy will give me 4b. This guy minus this guy will give me plus 4c. So if I divide through by 4, it means that my common difference is in terms of b and c. So my common difference is b and c. So they say find the first term and common difference. We have gotten the common difference. So the next is to find the first term. How do we find the first term? We substitute this into any of this equation. So I'll pick a plus 6d equals 7b plus 5c. So a plus 6 bracket, what is our d? B plus c equals to 7b plus 5c. So a plus 6b plus 6c is equals to 7b plus 5c. So if I take this guy to the other side of the equation, I will have 7b minus 6b plus 5c minus 6c. So 7b minus 6b will give me 1b. The 5c minus 6c will give me this guy. So it means that my first term is this and my common difference is this. Now we can also try this out. If to get second term, I will add common difference to it. If first term is this, let me wipe the board. If this is the first term, first term is b minus c. To get second term, we just have to add common difference, which is b plus c. So this plus c will cancel out with this. We'll get 2b. To get third term, we just have to add plus common difference again. This is 3b plus c, right? To get fourth term, we just have to add common difference again, which will be 4b plus 2c. To get fifth term, add again, we'll get 5b plus 3c. To get the next one, to get sixth term, we'll get 6b plus 4c. Seventh term, we'll add again, we'll get 7b plus 5c, which is what was given in the question. So let's solve the last question for today. So the last question says, if these guys form successive terms of an AP. So it means that the AP have other terms, but they just pick out these three consecutive terms of the AP and said, let's find the next four terms. So first of all, we can do it the way we solved this guy and this guy. We can choose not to do it that way. So common difference is this minus this. So 5x minus x, or this guy, 6x plus 9 together is our other one, minus 5x. So either you do this minus this or this minus this. So 5x minus x is 4x. 6x minus 5x, that gives us x plus 9. So if I take this guy to the other side, I will have 4x minus x, which is 3x. So if I divide both sides by 3, my x becomes 3. So if I substitute this guy back here, it means that this consecutive term is actually x, which is 3, 5x, which is 5 times 3, that's 15, 6x plus 9, 6x is 6 times this, 18, 18 plus 9 is what? That gives us 27. So they are telling us that these are these terms. We are looking for the next four terms. So what's the common difference? 15 minus 3 is 12. This minus this will also give you 12. So to get the next term, I have to add 12 to this. 12 plus this, that gives us 39. Plus another 12, that gives us 41, 51. Plus another 12, that gives us 63. Plus another 12, that gives us 65, 75. So these are the next four terms of the sequence. And that will be all for this video. Please do not forget to like, share, and subscribe to my YouTube channel. Thanks for watching.